Part 3. Number 5. We're going to expand logs. I want you to make log of the numerator minus log of the denominator, which is b cubed square root of c. This log right here, I can toss the 2 in the front and make it 2 log of a. And here I'm going to expand them into 2 separate logs, log of b cubed plus log of square root of c. Now remember, you have to put the negative here in the parentheses. To expand some more, getting rid of the exponents, that will give you negative 3 log of b, and this will give you negative 1/2 log of c. Part b. I'm going to expand these log of the numerator, 3x to the 5th, minus log of the denominator, which is x plus 1 to the 9th. Here I'm going to have to separate the logs before I toss out the exponent in the front, because the exponent is only on x to the 5th. This one I can simply make it ln 9 ln x plus 1. Now the last thing I need to do is take that 5 and put it in the front, and that will be ln 3 plus 5 ln x minus 9 ln x plus 1 has to remain in parentheses. You cannot condensing logs. Before you can condense log, I need the exponent to go away. You cannot condense logs if you have a coefficient other than 1. This is going to give you a log of x to the 5th. This is going to give you a log of x squared plus 1. The whole thing is going to be raised to the 1/3. This is going to be log of x minus 1. The whole entire thing raised to the 4th. Now we can start combining logs. We combine those two by making them a single log of x to the 5th divided by x squared plus 1 to the 3rd. And we still have to add this quantity, log x minus 1 to the 4th. Now when we add two logs, it's going to be the same thing as the product of the logs. And this is going to be x to the 5th times x minus 1 to the 4th divided by x squared plus 1 to the 3rd. All of this has to be in bracket because this is a single log. Okay, condensing these type of logs, I can condense these two because both of them have a coefficient of 1. That will give you, because you're adding them, their product, x plus y, x minus y. And now this one here, I'm going to get rid of the coefficient and make it ln z squared. Now these, I can condense some more is the difference of 2 squared, x squared minus y squared. And this one is going to be ln of z squared. Combining these two logs is going to be their quotient, which is x squared minus y squared divided by z squared. And this is all have to be put in a bracket and done. Okay, number 7. I want you to change the basis to common log, and this will be common log of 5 divided by common log of 7. Changing basis here will be common log of 2 over common log of 5. If you reduce these, the answer should be log of 2 over log of 7. We can go ahead and put them as a single log by changing the basis to base 7 of 2. Next, we're going to look at part B. At part B, whenever you are subtracting 2 log, you're allowed to condense them and make it log base 3, 189 divided by 7. 189 divided by 7 is going to give you log of 9. Log of 9 is going to be 3 squared. And so log base 3 of 3 squared, take the 2 and toss it in the front. And so that will be 2 times log of 3 base 3, which is 1. And the answer will be simply a 2. Finally, for this problem, number C, part C, I want you to change this to log base 5 of 625 to the 5th. Now 625 is 5 raised to the 4th, and so that will give us log base 5, 5 to the 4th raised to the 1/5, which is the same thing as log base 5 of 5 to the 4/5. If you take the 4/5 and put them in the front, so the answer will be 4/5 log 5 of 5, which is 1, and the answer simply. Okay, graphing 2 to the x. This is a parent function, x and y. Negative 2, negative 1, 0, 1, and 2. 2 to the negative 2 is 1/4. 2 to the negative 1 is 1/2. 2 to the 0 is 1. That's a 2. That's a 4. When we go in to graph it, this is an exponential growth function. At negative 2 is going to be this small. At negative 1 is going to be a half. At 0 is going to be 1. At 1 is going to be 2. And at 2 is going to be 1, 2, 3, 4. This is the exponential growth function. Now, what's the domain of this function? It's always going to be negative infinity to positive infinity. The range is from 0 to infinity. The horizontal asymptote here is going to be y equal to 0. There is no x-intercept, and there is a y-intercept at 0, 1. This is your y-intercept. Part B. This is the exponential function that we just did earlier, and I'm just shifting it down. I already set up the table for you for the parent function, and now I'm just simply going to shift it down by 3. Shifting down by 3, you're just going to subtract the 3 from all the y-axis. Subtracting 3, what's 0.25 minus 3 is going to be negative 2.75. 0.5 minus 3 is negative 2.5, and 1 minus 3 is negative 2, and then 2 minus 3 is negative 1, and then 4 minus 3 is going to be a 1. I need you to do this parent function as dashed, and this is going to be a solid function. And so when we go to the graph here, the parent function is going to be exactly, at 1 is going to go to 2, and at 2 is going to go 1, 2, 3, 4. This is the parent function. We're just going to have to make it dashed. And then when we move the function 3 down, I need you to remember, every time you move the function down, I need the asymptote to move down first. The asymptote is part of the graph that must be graphed. And so negative 2 in this point, negative 1 in that point, negative 2 here, 1 in negative 1, and then 2 in 1. This is the solid graph. Now when we find the domain is for the solid function from negative infinity to positive infinity. When we go ahead and find the range is going to be from negative 3 to infinity. We have a horizontal asymptote here at negative 3, and you must put the y equal negative 3. We do have a y-intercept here. How do we find the x-intercept? To find the x-intercept, what I want you to do, make y equal to 0. If you make y equal to 0, you end up with 2 to the x minus 3 equal to 0. Okay, how do we solve this? We're going to solve this one by making it 2 to the x equal to 3, and then log both sides. X log 2 is equal to log of 3, and then x is going to equal to log 3 divided by log 2. And if you go to your calculator and estimate this number, it should be pretty close to 1, maybe a little over 1.6 maybe. And then the y-intercept, as you can see from the graph, the y-intercept is right over here. This is the y-intercept. I don't need to do it. The x-intercept was a little bit over 1.6. And this is going to be my y-intercept, which is already in the graph. Alright, part C, we are shifting this graph by moving it to the right one. I already have the parent function ready for you. To the right one, we're going to add 1 to all the x's. Negative 2 plus 1 is negative 1, plus 1 is 0. 0 plus 1, 1 plus 1, and then 2 plus 1. The y value, they're going to remain the same. We're just simply moving the graph to the right one. Okay, let's go to the graph and figure it out. The parent function, it's going to be the same. 2 to the x, and now when we move right and left, the horizontal asymptote doesn't shift. At negative 5 is going to be 0.25. At 0 is going to be 0.5. At 1 is going to be 1. At 2 is going to be 2, and then at 3 is going to be 1, 2, 3, and 4. So this is the graph that's an exponential growth, just shifted to the right one. The domain is negative infinity to positive infinity. The range is going to be 0 to infinity. The x-intercept is impossible. This does not cross the x-intercept. The y-intercept is right here, already have it. And the horizontal asymptote stayed at 0, y equal to 0. And J, I'm going to do them together because they're inverse of each other. So I'm going to start with F. This is going to be 0.1413. This is going to be 0.4. This is going to be 1. This is 2.7. This is 7.4. Now, you know when you get to J, all what you need to do is reverse these so you don't have to repeat them. because you always want to start with an exponential function and do the inverse to get to the log function. So this will be 2.7 and 1. This will be 7.4 and 2. So what I'm going to do, I'm going to graph both of them on the same graph, but I'm going to use different colors. And so here is my graph. I'm going to do the exponential function in blue for you. So a negative 2 was 0.13, a negative 1 was 0.4, a 0 was 1, 1 it was 2.7, and a 2 is going to be 7.4. That's 3, 4, 5, 6, 7. So this is the exponential function. And then if you notice the inverse of that, 0.13 is going to be negative 2. 0.4 was negative 1. 1 was 0. 2.7 went up to 1, and it was 7.4. 3, 4, 5, 6, 7 was here. This is going to be the log function. Now for each function you can tell that these are reflections with respect to each other with respect to y equal to x. For each function we're going to find the domain, negative infinity to positive infinity. The range here is going to be 0 to infinity. Here we have a horizontal asymptote at y equal to 0. We have no x-intercept, but we do have a y-intercept at 0, 1. Now for the log function, this is the ln x. We have a domain that was a range over there, and everything is going to be flipped. The range here will be negative infinity to positive infinity. Here we have a vertical asymptote at x equal to 0. And then a couple more things, the x-intercept and the y-intercept. Here we have an x-intercept at 1, 0, and we have no y-intercept. Alright, part K, we need you to start with 2 to the x and pick up the same exact value for x. Negative 2, negative 1, 0, 1, 2. These are 0.25, 0.5, 1, 2, 4. Then we're going to go to log base 2 of x, which are the inverse of these points. And so this will be 0.25, negative 2, 0.5, negative 1. 1, 0, 2, 1, 4, 2. Then we're going to go ahead and shift it to the right one. When we shift to the right one, all we have to do is add 1 to all the x's. So 1 plus 0.25 is 1.25. This stays negative 2. 1.5 stays negative 1. 2 and 0, 3 and 1, 5 and 2. Let's go ahead and graph these on the same coordinate plane. Okay, I went ahead and I graphed the last function before it was shifted, and next what I wanted to now graph to the right one. When you shift to the right one, I need you to shift the asymptote to the right one. You must graph the asymptote first. And so now this point will be shifted to the right one, this point will shift it to the right one, this one here to the right one, and this point to the right one. So my graph should look something like this. Of course, if you keep the table of value up there, it will be fine. So now let's go ahead and state the domain and range. Domain is always going to be from positive 1 to positive infinity. The range here is always going to be from negative infinity to positive infinity. We do have a vertical asymptote at x equal to 1. We have an x-intercept at 2, 0. We do not have a y-intercept. Okay. All right, part M. Part M, I need you to rewrite the equation as log base 2, negative, factor it out, x plus 1, plus 1. The reason we want to factor it out, because this tells us to reflect over the y-axis. And then it tells us this one shifting left 1 and then up 1. We're going to go ahead and start with the table 2 to the x, which we already done it several times. Then we're going to do log base 2 of x. And then we're going to reflect first, and then we're going to do the shifting. Now, while I'm constructing this table, we're going to go left and up. I'm going to go ahead and construct the table, and then I'll be right back. Okay, now that I filled in the table, I want you to look at 2 to the x, flip them to get to the log. Reflection, I changed the sign on all the x's. And then left 1, I subtracted 1 from the x's, up 1, I added 1 to the y's. Okay, I graphed the reflection in pink and I graphed the shifting in blue. The only thing I need you to remember here, because we're shifting left 1, I need you to put the asymptote at -1. So finally here the domain will be from -infinity to -1. The range is from -infinity to +infinity. The vertical asymptote is x equal -1. The x-intercept